So what I wanted to do is try to summarize what we just talked about. And if you look at this table, I'm just going to repeat what hopefully the audience has heard and kind of look at it in a tabular format. So if you look at from the left to right, the PCAPs on the left and flow statistics to the right, you can see a pattern emerge, which is give you the highest level of visibility. Basically, you don't have packet loss or information loss. And the flow statistics give you the highest level of abstraction, but also, give you not the assurance that you have all the data sets that you need to look at. You need all of them. On the PCAP side, obviously, it comes with the cost of storage, the processing, and the amount of throughput needed to be able to create those is almost equivalent to the actual data rate on the network. And it's not the most suitable as we moving forward to this new paradigm shift in the big data, visibility or big data infrastructure as we're trying to take the network data to that. So it's not going to be the one that lends itself the best into the actual big data infrastructure, just because of the, analogy you gave, like a linked list, right? So it doesn't allow you to, dynamically address what you want to get out of it. You need to have those offsets. The metadata, it's one layer of abstraction and then an evolution towards that, which we do need to be able to get some inference of the data about the data. It comes with, less overhead on the storage, processing, and about 10 to 20% relation to the network data itself for creating those metadata. It's a lot more suitable as we move to the big data, and in fact, many of the purpose tools are already creating those kind of metadata, and we'll talk about some of the different types, whether clear text or binaries, and they're typically applied for a network performance monitoring, application performance monitoring, or forensics, where you need to have more of a contextual intelligence about that data set. And the flow statistic would be the next level of abstraction, which allows you to create this baselining, right? I mean, back in the day, a lot of IDS and IPS started kind of looking at it, and some SIMs started using net flows to kind of, infer what was happening in a network, right? The network behavioral analysis tools were trying to do this initially. So similarly, on the big data infrastructure, the flow statistic will have a play in to be able to set up those baselines. And, I would look at them as like an early warning system, whether it's from security or customer experience or user experience or performance analytics, right? You kind of know what the norm is. On your Monday, everybody logs in. You kind of have a historical baseline, and then you kind of see spikes going. Now, this could be from a security perspective. It could be something like detecting beaconing, for some botnets trying to come back, because otherwise you wouldn't see it. There's such a small, frequency of them that are happening. So that kind of summarizes what we looked at as far as the data types. And moving on, I guess the question I have at Wade is, so why is it that we're not there yet? Well, what are some of the roadblocks of not using this network data? We all agree that it can provide a lot of intelligence into it, and we saw that only 0.5% of it is being used today. So let's talk about that for a second.
Right. So I think we agree that bringing network data into the big data stores is valuable. Hopefully, by this point, our viewers are beginning to at least see some value to doing that as well. So some of the stumbling blocks. So the biggest stumbling block has been the fact that the network links have gone from 1 gig to 10 gig, 40 gig, even 100 gig now. So there's a huge amount of data that's traversing the modern networks, and capturing this network data is difficult. So we need specialized technologies such as the NPBs to be able to even keep up with the kind of volumes that we are seeing right now. The existing ways in which network data has been traditionally captured, which is the capture cards, network recorders, network analytics probes, all of these are not able to keep up with this change in the network data speed. So now, for example, with network recorders, you have a given speed and you have a given amount of storage. The moment you run out of the storage, you need to buy a new network recorder, which is expensive. Now the network recorder works at, let's say, 10 gig. The moment you transition your network to 40 gig, you need to buy a new network recorder. And with the analytics probes, which combine the capturing, the storage, as well as the analysis, let's say you want to do a new type of analysis on your network data and the analytics probe that you have doesn't support it, you need to again buy a new probe. So the point here is that regardless of whether you are at a higher network speed than what your infrastructure supports, whether you are running out of processing power, you need new analytics, or you're running out of storage, the only solution with the existing paradigm is to buy a new box, which includes all four and is expensive. So that's a big problem here. And moving to the big data solution will help you kind of move away from this non-granular way of scaling things, and instead allow you to granularly scale only the resources that you're running out of.
So Adwait, what I heard as we talked about this, it seems to me that once again we are, hitting a wall, and the challenges that I heard you talk about is around cost, which to be it's just not feasible at this point to be able to put capture cards everywhere on the network if you want to have that level of visibility, because really if you're talking about bringing that network data, you want to see everything, so it's cost prohibitive. It's an issue of scale, right? Like how are they going to keep up with these volumes and velocity data, and obviously the efficiency, right? Does it make sense to create these stovepipes, or in this case, pools of big data, if you will, right? That each one of them is creating their own, right? And now you can, looking at it from security, now you have to do the same thing for business analytics and whatnot. Again, it's the same network data. Why do it so many times? So it's an issue of cost, scale, and efficiency. I'm sure as, we're trying to capture all this data, right? There's this concept of, within big data, to separating the actual capture layer and analytics, right? So we're talking about actually democratizing, and kind of opening this up. And today there's two different approaches, right? Because this data has to be stored somewhere. We're talking maybe going from directly acting on the packets, decoupling it from time as well, and putting it in a big data store, and you kind of aggregate all this data sets, way that multiple tools, analytics can go and grab what they need. So with that said, let's just talk about, what are some of the storage formats?
Okay, so yes. So before we go into the architecture that we're talking about here, there's this one final piece that we need to talk about that forms a part of the entire architecture: the storage. So what formats can you store the data in? Now, proprietary formats, that's kind of the more Apple way of doing things, where data, the way in which you store that data and the processing that you do on that data are all tied intimately together. So the advantages are obviously that it could be a better processing time, because the data is optimized, and also you could probably compress the data in a way so that you need less storage space. But the downside of that is that you're locked into a particular vendor. So if the data belongs to a given vendor and is stored in their proprietary format, there's no way any other tool that you have can access that data. So now what you need to do is to access the same data. Each tool vendor needs to perform the capture. Each tool vendor needs to store the same data in their individual proprietary formats and then access it. So that's kind of inefficient. So on the other hand, we have the open format of storing data, which is more the Android model, if you will, moving forward with that analogy. So with the open format, you have no data lock-in. The data can be accessed by any tool, any vendor. So you can capture the data once, and each tool can access it whenever needed. And the other thing in favor of open formats is that data is future-proof. So if you capture data today, and let's say you have the stored data for the last month, and you have a security breach and you wanted to investigate what happened, you can go out and buy a tool, and that tool will be able to inherently access all the data that was stored for the past month, 2 months, whatever you have, without a problem. So all the data that you store is future-proof. And so finally, we're talking about the architecture that we have been talking about so far. On the left, you can see that we have the traditional network monitoring architecture. So you have the production network, which is not shown in the slide. Above that is the NPB layer, which is at the bottom of that slide on the left side. And the NPB layer then captures the packets, optimizes them, filters them, and then hands them off to individual tools in the raw packet format. And the individual tools can then be the VoIP analysis tools, APM, NPM, what have you. And these tools then need to individually capture these raw packets, store them, analyze them. What we see the world moving towards is the architecture on the right-hand side, where the NPB layer, instead of handing off raw packets, now creates metadata or creates PCAPs and then hands them off to a standard storage layer. The standard storage layer will be open format storage, which just stores this data and makes it available to individual tools. On top of that, we see a processing layer, for example, Hadoop. and then the individual tools in a virtualized way work on this processing layer. So the VoIP analysis, NPM, APM can all use the processing resources to access the data that's been stored in the open format and perform the functions that they have been doing so far. So what this gives, the advantage of this is that each layer and each company can specialize in a given layer and a given technology. So the NPVs such as us, we are specialized in just doing the capture. The storage layer is specialized in storing that, while the analytics vendors can concentrate on what they specialize in, which is analysis and coming up with interesting insights, and they don't need to worry about capturing data nor storing data.
Thanks, Adway. So one of the things I wanted to make clear on this slide, at least, where I'm looking at this, we're not just talking about this, Adway, that this is happening tomorrow, right? This is an evolution we're talking. I see this as an inflection point, right? Much like what we saw when typically there were taps and aggregators trying to feed the network monitoring tools, and we saw contention around the span port, again, efficiency, scale, and whatnot. We needed to do load balancing, went from 1 gig to 10 gig, and we created this layer of packet capture and delivery into the tools. There's going to be some time that the NPV is going to be delivering packets to your tools, but we see it as an inflection point where we need to move towards this, because otherwise you're paying too much, you're not going to be able to keep up, and it's just not, you're not going to have the level of efficiencies that you have. So this is very much in line with what we've seen. This is yet another inflection point where we are going to be providing both synchronous data delivery to the tools and asynchronous delivery through a big data platform. So with that said, I think, Anna, this is probably a good time to pause and maybe, if you have time, to get some of the voting.